question 5 is asking to find the confidence interval for 95% and the margin of error that is part of that, and the point of estimation of the mean, given 11 observations here from a normally distributed population. So if we go back to our cases here, if we have a number, or if we have a sample data points for a number that is less than 30, we need to know the population is approximately normal to be able to use the t-distribution to estimate the mean. So those conditions are satisfied, so we're going to use the t-table. What is the point of estimation? Here is going to be the summation of the summation of x divided by n, in this case 11, and doing that math, 1.41. So that gives us the point of estimation, x bar here. Again, for the confidence interval, we need to find the standard deviation of x bar, which is s over the square root of n. But s is going to be our sample standard deviation, is going to be approximate there. So to do that, we use that same formula we had above. With 11 data points here, and I went ahead and let Excel do this work for me, and so I added up, or I wrote down the 11 data points, and I summed the 11 data points here, and then I squared each one of them and summed them up, and then I did the math there, and then the square root here was 7.2266542. Then I divided that by square root of n. In this case, n was 11. So dividing that by the square root of 11, I got this here. So S was 2.178884. Oh, sorry. S bar was this. So setting us up, I have the mean, the point of estimation about the mean, x bar, plus or minus t times the standard deviation about the mean. So I want to find this t such that I have a 95% confidence. So drawing the curve, my degrees of freedom is going to be 11 minus 1, which is 10. And I want 95% here. So 1 minus 0.95 divided by 2, that would be 0.025, 0.025. So I'm looking for a t value that gives me 0.025. So go to the t table. I'm looking for the degrees of freedom for 10, and I want 0.25, and that gives me 2.228. So t would be 2.228. So I have, and be careful here, this was calculated as 1.4091, so you might want to leave it like that in your second calculations. 1.4091 plus or minus t times the point of estimation of the standard deviation about the mean here. This part right here is what's known as the margin of error. Right? 95% will fall in plus or minus this margin of error. So you've already kind of calculated it there. 0.228 times 2.1789. That gives you 4.85458. This is your margin of error. If you take 1.4091 plus or minus that, that would give you minus 3.45 to 6.26. So hopefully that helps clear up what's going on in question 4 and 5. If you have any other questions, please let me know.